Let's go. Subsea pumping technology. What is that?
It's basically taking conventional equipment that we have on topside platforms and taking it subsea and increasing our...
Hang on, so all the stuff that's on the deck, no longer there. Subsea. What does that matter?
Well, so you can do it with the umbilical. When you're putting an electric tree down subsea on a wellhead, and you're going to still need the chemicals at the well, you're still going to need flow assurance, you still have the capability of having that with subsea chemical storage at the well and injection at the well as well.
No, you got two things: subsea pumping technology, subsea distribution products.
Yes.
What's that?
Oh, so subsea distribution, it's more the conventional way we would do a tieback for subsea field event.
What's a tieback?
So we control the trees that are down there. So
and what's a tree that's down there?
So the trees are what is a bank of valves that actually produces or pulls hydrocarbons out of the well. The well's already drilled, and then flows those hydrocarbons back through a manifold all the way back to either a floating vessel or back to shore.
And we take care of all that.
We control those trees down there, basically.
We're going to let you off the hook, Michael. We got a long way to go, buddy. Thanks so much.
Well, let's see you.
Bye. So let's go down here. I see Stevie Buquoi. Let's go get him. Stevie, you don't know that we're going to do this, but we're going to stick a microphone on you.
Hello, hey, how y'all doing?
I see pipeline connection and repair systems. What is that, Steve?
Pipeline and connection repair systems is where we have fixed pipelines that have like some kind of ruptures or little pinholes in it to where...
Okay, so if there's something going on subsea, it's a pipeline.
Right.
Maybe there's some corrosion.
Right.
There's a leak or something.
Right.
Are you saying that we can fix that?
Yes, we can fix that with two pipeline interconnectors, as you see right
Okay,
here.
let's take a look at it. What is it?
So this is our new SF4 connector that we just designed. It's good for undersized pipe. For undersized and over 1% API-IL.
Okay, too many complicated words.
I understand.
What's undersized pipe? What do you mean?
Undersized. So if the pipeline is a 16-inch pipeline, and if it's under like 15 inches, so that's under.
Okay.
So this will compensate for being under.
Okay.
You'll tighten up the bolts.
And that creates a seal to stop any sort of leak?
That's right. Come on over here. Let me show you
So
something.
come on.
Well,
He's telling us where to go.
so once we tighten up on these end bolts, cap bolts right here, on the inside, we have a couple of seals in the inside.
And that's right here.
Yes, sir.
Okay.
Right there. So once these bolts are pushed in, what it'll do is cause a seal to the OD of the pipeline.
The OD is the outside diameter.
Outside diameter, right? That's right. And then it'll collapse this gripping seal right here to the OD of the pipeline. Once all this is all set and done, then we can do a full test on here to make sure these seals are good on the inside. So we'll just do like an annulus test. That's what it's called, annulus test.
Make sure it's not leaking.
Make sure it's not leaking.
Oh, we're going to let you off the hook, man. We got a lot of boots to go.
I love you, brother.
All right, brother. I'll see you later, man. Bye. Rotator Technologies, like I give you 3, 4, 5 sentences. What exactly is that?
So, two main types of products: chemical injection valves, directional control valves.
Okay.
We have subsea and topside versions of both. We focus mainly on the subsea.
Okay.
But these control valves are basically parts of a subsea control module, and they control multiple functions on a subsea tree.
Like what?
Like opening and closing a gate valve, for example.
To let in
Safety
different
valve.
chemicals and stuff like that, or?
Chemicals, or control the actual flow of petroleum and gas.
Okay.
Through. So all the controls, there's typically 20, 22 of them on a given tree. They're controlling all the different functions.
Okay, and we got a video coming out where your team explains to me the difference between this and this.
What this is going to do is be subsea, and it's going to inject a different type of chemical straight into the production flow to optimize that flow. So it's going to prevent scale buildup or corrosion, and it's all going to be coming through this valve in a very, very accurate dose for the life of the well. So this is designed to go down to 4,000 meters at 15,000 PSI, 1,000 bar, and just work for 30 years.
Oh, did you say 4,000 meters?
4,000 meters.
Working on. I'm looking forward to it, buddy. We'll see you later. Okay, bye. All right, I see the Grayloc people over here, and they're not really doing anything. I guess, although talking to Rod's probably doing something, let's go interrupt them anyway. So we're going to interrupt you guys because we're on a tight schedule, but I want Rod to take over, and I want Rod to ask Steve what Grayloc's all about. Take it away, Rod.
All right. Okay, tell me something I don't know about Grayloc.
So the Grayloc connector it's a clamp connector used for high pressure critical service piping applications for offshore oil and gas, petrochemical and refining, defense, aerospace, food processing, just about any place where you got 2,000 psi or higher, and also used in high temperature applications. The one we're just talking about from Purdue, it's 1,400 degrees Fahrenheit and about 3,000 psi. That's a lot of pressure for that kind of temperature. And that's the reason why they use that Haynes 282 material.
So there's a lot of flange connectors,
Yeah.
flat flange bolt connectors out there. Why is a Grayloc connector superior to a flange?
Our connector is superior to a conventional flange because we have a metal-to-metal zero leakage seal. Means zero fugitive emissions, so you don't have to worry about that. It's very reliable, field proven. We've been making this connector for over 70 years now. It's very easy to fabricate. You weld your two hubs to your piping just like you would with a conventional flange, except you don't have to worry about clocking your bolt holes right. So it makes fabrication easy. We've only got 4 bolts to put the connection together. A conventional flange can have as many as 24 bolts to put together. So it's a lot quicker, it's much lighter, it's very robust, typically has higher pressure ratings than its counterpart in the ANSI flange.
Less sensitive to torque around the flange and...
That's right. Less sensitive around the torque.
So the next question is, how does Grayloc compare to the market? Where do you fit in the hierarchy of the market? Who's the best?
Grayloc's the best. I mean, like I said, it's a 70-year-old product line. We are synonymous with other brands like Kleenex, Coca-Cola, Xerox. Somebody sees a clamp connector out in the field, and they automatically think Grayloc.
Yep.
So that's where we are. We're the top dog in the industry.
And what's the next big thing?
The next big thing, I don't know. We're hoping to do some additive manufacturing with some clamps and exotic alloys. We're hopefully this year we'll get into some application or project.
Very, very
where we
cool.
can do that.
I'm never giving the microphone to you again because you do a better job interviewing than I do. All right. What are we looking at here? I'll just let you explain the whole thing.
Yeah, absolutely. So this is the Engineered Solutions booth. And Engineered Solutions is a portion of the Offshore Projects group. And what I like to say is the Engineered Solutions bread and butter is solving challenges both for internal and external clients.
All right, so what am I looking at here?
So what you're looking at here is a portion of a tooling suite that we provided for our client. This is called a jacking tool. So if you can imagine how you jack a car if you got a flat tire.
Right.
It's similar in function. It's a hydraulic jack that we use to remove a portion of an actuator subsea.
Okay, tell everyone what an actuator is.
Yeah, so it's an actuating portion of a valve that opens and closes a valve subsea. And what our client challenged us to do was they had a potential leak subsea.
A potential what?
A potential leak subsea.
Leak, okay.
So they wanted to gain access to the portion of the valve where they thought that the leak point was.
Well, underneath, apparently, because you had to have the jack, is that right?
Yeah, that's true. So what you see behind me over here.
Hang on, over here. Can you get this? Okay, go ahead.
So this is our elevator frame. So these two tools were actually used in conjunction with one another. But this locks onto an interface on the top of the valve actuator, grabbed onto it, and used a hydraulic cylinder to lift it up and out of the plumb safely. So if we were using a crane, there was a lot more risk associated with it because it wouldn't be pulled up in a controlled manner. So this elevator frame mitigated that risk and was able to remove that plumb in a controlled manner, the valve actuator in a controlled manner from the plumb. It did take a considerable amount of force to be able to pull that valve actuator out from the plumb. And that's where this jacking tool came to play. It gave it a little bit more oomph. And it was a contingency tool initially. We also provided a lot more ancillary ROV tooling to be able to do a cleaning, gain access, and do a visual inspection as well. But in short, our client came to us with a very open-ended challenge. And from start to finish, we did an engineering feed study, a front-end engineering design phase for us to come up with a solution that was customized to our client. And
Awesome. Now let me ask you, did we solve the problem?
We did. Yes, we did. And it happened in about a 10-month time frame.
Awesome.
We probably came up with 10 different tools, and it was a success offshore. And I think at the end of the day, you know, we solved the challenge that we were set out to do.
That's awesome. Thank you for letting me just walk up on you and stick a microphone on you.
No worries.
All right, I'll see you later. Okay, bye. All right, Gordon, I bet you thought you were going to get away without being interviewed, right? Nice try. Integrity Management and Digital Solutions. What's going on in your booth? Well, today we're demonstrating our kind of digital asset management side of the business. So over here we've got the Informed Vision. Oh, let's come on. Let's take a look. What are we looking at? We're looking here, Informed Vision. This is essentially how we're performing digital asset management nowadays. What does that mean, digital asset management? Tell me what you mean. So it's really about the visualization of plans, the visualization of data. So this is that. Is that right? This is more for the engineering side of it. This is more for the visualization. So on one side of it, you can do repair, maintenance, redesign, and the other side, you want to look at the condition of it. So we have it in both representations. But really what we're really trying to do is bolt on all the less visual stuff, which is the back-end engineering. So how we perform the engineering analysis, how we perform planning, and how we're making it more efficient. So this is the visual side of it, but behind that, you've also got all the engineering. How does that benefit the customer? Faster, speed of insight. We used to say that they're probably going to have less people, but now what we're actually finding, the customers are using those people more effectively. So we're getting like 4 times the engineering time, or being more effective to 4 times. And we're clearing backlog faster than we've cleared it before. And people are spending time on the value add rather than down in the paperwork, down in the admin, and what's not value add. Down all the boring stuff. In the super boring. Right. Gordon, I'm going to let you off the hook. Thanks for the ambush. Yeah, I wish I knew that was coming. No problem, man. I'll see you later. So you know what? We're going to interrupt you guys because you're explaining it all to Jennifer, so you can explain it to all of Oceaneering, Martin. Jennifer, before you leave, you've been with us for how long?
5 years.
And who else works? Your sister?
My sister, Lisa McCrory, she's an IMDS.
And how long she been here?
I think 17 years.
And here comes the good question. Your dad, how long was he here?
My dad was here from 1981, 82. Yeah. So a long time, and he retired from Oceaneering at 2022.
All right, so it's a family business. It is a family, and you've been here 35 years, Martin. All right, so 35. I'm gonna give it back to you in 1 second, okay? Tell us what you were telling Jennifer. What exactly is going on in this booth, Martin?
So I was explaining to Jennifer the different facets of where each of the Oceaneering businesses play. So starting over here, with the jumpers. OPG will install the jumpers along with SSRs, ROVs, that will help connect up the jumpers.
Right, and this is a jumper, this piece right here, right?
Then the control umbilical here. It's a control umbilical, manufactured product, so manufacture that. We will help to install and connect up the subsea termination heads. Right? And then we'll come and do interventions using our skids under the trees for...
So show everybody what the skid is.
Here's the skid here.
Okay, the lower part, right?
Skid, yeah. Could be a BOP intervention skid or a hydrate remediation skid.
A BOP, blower preventer, okay.
Yeah. And then we've got Freedom over here surveying the pipeline for integrity.
Okay, and Freedom, just in case they don't know, this is our Freedom vehicle. Okay.
And then over here, we've got Liberty. So Liberty's over here.
And Liberty is what?
So Liberty's our freestanding vehicle that's electric. Part electric vehicle with some hydraulic capabilities that is currently working in the North Sea. It's controlled from the surface buoy here.
So what is this? So this buoy is connected to it. What does that do? Is that for communications, or how does that work?
So that communicates via the satellite or via the 4G network back to any one of our remote locations. But right now it's operated from Norway, from our remote operations center in Norway. So the ROV skirts out from here and will perform functions around any one of the subsea production systems, or it'll be doing inspections, and it's all handled remotely. And then a vessel of opportunity Could be any one of ours, or another customer vessel will come along and pick it back up again and then go and do another.
Well, let me ask you this. They're flying an ROV around the corner. We're getting ready to go talk to them. They're flying an ROV from here in Houston, and the ROV is in Norway.
4,800 and something miles away.
And we're flying it from here.
We're flying it from here. And
theoretically, they could fly that one as well. Is that what?
that console there could fly this one too.
So that, again, the console sitting right around the corner in this building could fly that ROV from here.
Yeah, and we could pilot it from Morgan City, somewhere else in the world. We can pilot it from Brazil, somewhere else in the world, Norway, and Aberdeen.
Crazy technology. I'm going to steal your microphone. Jennifer, I'm sorry we broke in here. We're going to move on. Thank you, Martin. You're a gentleman. All right. Now, I'm wondering if this guy can fly the ROV and talk to us at the same time. I don't know. Let's find out. I didn't realize it was you flying the ROV.
Still got it.
Can we ask you some questions and you fly the ROV at the same time?
Not sure I can multitask, but
We're going to see. Come on around here, Will. What are you doing right now exactly, Mark?
So this is our new electric Millennium in the tank in Morgan City. Just coincidentally, we're in the tank the same time as they're testing it. So we just thought we'll take the opportunity to operate the ROV remotely from here to show the visitors our new ROV test bed as it's such. Our new ROV won't look like this, but it's got all the bits and pieces that will make the new one work.
Okay, I want to make sure everybody understands. You're sitting here in this chair in the high bay in Houston, and you're flying that ROV. This one's in Morgan City.
This one's in Morgan City, and I left that part out because it's kind of second nature to me, so I guess I didn't think about it. But yes, Morgan City, several hundred miles away.
So you don't have to be on a rig. You don't have to be at the location. You can be at one of our our onshore remote operation centers.
Or on my sofa.
Or on your sofa.
Yeah.
What's the advantage of this? Why would a customer want this?
So a bunch of advantages. So we can reduce personnel on board, which so many customers this morning talked about bed space issues.
You mean literally where people sleep, bed space, there's not enough room. Okay.
Not enough room. In my day, what they did was they moved the top bunk down and they put another bunk above that. They don't do that anymore. So they're faced with building more accommodation.
Right.
Expenses, and they don't always have the space. So this allows us to put some of the people on shore. Also gets them away from a hazardous workspace, right? Also makes us more agile. If they're running a 12-hour shift offshore and suddenly the customer has a problem, they need us to be there 24 hours. We can quickly mobilize people here much quicker than we can send them somewhere.
And I'm thinking about my past life. If you were on my job and there was something going on, I could literally just go down the street, go into the the onshore remote operations center, and take a look at what's going on and talk to you without actually having to go out to the rig.
Right, and because you're virtually present. If you see on the screen, we have a Teams meeting. So the folks on the right are the team in Norway because we were flying that ROV moments ago. The ones on the left, that's the team in Morgan City that's looking after this ROV that I'm flying. So they could just as easily be offshore. So that's what we do during a job. We'll run a Teams meeting so we see and hear each other and collaborate just as if we were sitting next to each other.
Awesome. Well, Mark, thank you for letting me run up here and stick the microphone on.
I didn't bang into anything
you up,
yet.
All right, that's good. Thanks a lot. Thank you. You know, I see Justin Pizzitola down here, and I know he thinks he's going to get away without being on camera. Wrong answer, Justin. Okay, first of all, why is there no carpet in your booth? Everybody else has carpet.
Well, we wanted to keep it, I think it was because of you, man. Why do you know what that means?
Well, intervention. Tell me what's going on in this booth.
All right, so we're displaying Boris.
Boris, okay, hang on, Boris. What's Boris?
Boris is our riserless light well intervention kit. Boris specifically actually stands for Blue Ocean Riserless Intervention System.
I bet you're happy you remembered that right now, aren't you?
I am. No, we actually talked about it earlier today. But this came from an acquisition that we did almost 7 years ago for Blue Ocean. We took on well intervention. We've got this kit, and we also got Iris, which is...
Hang on. What is well intervention? I realize that's a simple question, but if you don't know, you don't know. What does well intervention mean?
So well intervention is any type of issues that a customer may have downhole in the reservoir, right? So below the mud line. We can look at it. We can go out with this system. We can hook it up to their tree, and we can actually.
What's a tree?
All right, Subsea tree. That is the control module that is used to control the production that's coming out of the ground.
Okay, and we can hook this up to the tree and do what?
That's correct. We can open up and actually send wireline and other types of tools downhole. So through our system, through the tree, and down into the reservoir.
Why would we do that?
We do that for lots of different reasons. They could have a sliding sleeve down in the reservoir that is not sliding properly.
Right.
So we send a tool down to actually slide it open. There could be other valves that are downhole that aren't operating properly. So we can send tools down and actually go and operate it properly. There's various other reasons. I can't go through all of them, but it's a lot.
I could ask you to, though.
You could.
I like you, Justin. We can stay here all day and talk about it. I'm going to let you off the hook, man. Thanks for taking us, giving us the overview.
You're welcome.
All right, man. All right. Excuse me real quick, Joe.
Hey.
Okay. Sorry, Joe.
We're live.
We're live. You can be in it if you want to. Joe, I've noticed the Oceaneers, everyone's coming through, and we had this massive crowd here before. What is this?
We got MaxMover and Unimover running. They're running a lift sequence that replicates what a manual driver would do. Now, this is not something we typically do with AGVs, AMRs, right? We're running it as though we're a manual driver just because it showcases the vehicle's capability. A lot of, 4 lifts in tight sequence. That's what we're showing there in the corner.
Why do I want this, though? Why don't I want just the guy to come in and drive my forklift around? Why do I want an automated forklift?
Oh, man, this guy, he doesn't take breaks. No, the safety system is thoroughly vetted. I know the engineering team has been very diligent in making a extremely safe vehicle. I mean, for one, I know we talked about it before. We don't have blind spot for this vehicle, right? Those scanners, those LiDAR sensors are expensive, and we've got a lot of them on there, full coverage. It sees all around it, and it stops if there's something in the way.
Awesome. Well, we're going to let you off the hook. We're just randomly sticking microphones on people, so you were the lucky victim that time. Thank you, sir. We'll talk to you later. All right. And Nick might be trying to run away, but we're going to stick the microphone on him anyway. Hi, Nick. What are you displaying here, sir?
This is Isurus number 9.
Okay.
So it is the 9th of our high-speed ROV.
Why do we need a high-speed ROV?
In the renewables market, in shallow water, specifically in areas where there are high tidal currents or oceanic currents, the currents can be enough that traditional ROVs can't actually maintain their position. When they can't maintain their position, the offshore operation shuts down. That could be for up to 6 hours a day.
So is this for only renewables market, or is it can be used anywhere?
It can be used anywhere. It's a fully capable work-class ROV, capable of anything that our Magnum vehicles are capable of today. But it also has that high-speed component. It's about 60% faster forward and about 40% faster side to side than a Magnum.
I guess is the right term station keeping? It can hold its spot while it's doing something?
Exactly. So it can hold its spot in high currents, particularly things that you see like in Taiwan or on the northern coasts of Europe where they have a lot of tidal.
And why'd you call it number 9?
Because we've got 8 in the field and this is our 9th.
So this one's not working, but the other 8 are out making us some money?
It is. This one just finished getting built, and so it's going to likely be shipping out of Morgan City to Europe for a contract in the next couple months.
Nick, thank you for letting me walk up on you and stick a camera in your face. I appreciate it. That's when you say thank you, Bill.
You're welcome. Thank you.
All right, buddy. We'll see you later. Kieran, I see Tim. Tim, we're just going to go. He doesn't know it, but we're going to stick a microphone on him, too. Sweet. Tim, how you like that? Oh, it's great. So, Tim,
Never had a microphone before.
what is going on in your booth? AdTech at this show. Tell me what's going on here.
Yeah, so AdTech, we're the Aerospace Defense Technology Group of Oceaneering. I work with the Oceaneering Space Systems Group down in Clear Lake. And on display today, we've got our crew module uprighting system, which is part of the Artemis program. It's flown in space, certainly not this 1/18th model.
I'm going to walk over to it because, look, it's cool, right? So let's come on.
So this is a 1/18th model, 3D printed model.
It looks like a space capsule that's got some basketballs.
So this is Orion,
right?
Certainly the orange-looking bags on top is the CMIS device that we built down in Clear Lake,
right?
Or designed developed and built.
Okay.
This is made to upright the system when it lands in the Atlantic Ocean, the Pacific Ocean.
Okay, can I lift it up?
Yeah.
When it lands, doesn't it just land and stay upright all by itself?
No. Most of the time, it's going to flip because of the way that the ocean goes. So as whether you have the ocean, the waves, anything that can happen out of there. Plus, you have your rescue recovery, your Coast Guard, your Navy, some of those other folks that are out there as well. Hopefully, they're not creating wakes. Making it a little bit more unstable. So the vehicle, or the crew, the Orion vehicle itself,
Like literally, it'll stop it from.
yeah. So once it's underneath, because one of the things they ran into with the original Apollo missions decades ago is how do you make sure that the astronauts can get out safely?
Right.
So what our system is designed to essentially operate to expand these bags kind of one at a time, and then they push it out, and then as they're expanding and pushing out and filling up with the gases, it turns the vehicle over so that way through the hatch, the astronauts can safely deploy.
Here's the hatch, though. They can get out through there. Tim, you didn't know we were going to come stick a microphone.
No, I didn't.
All right, well, you're off the hook, sir. I appreciate you taking us around.
No problem.
All right, so you bet. Oh, no, you got more. Wait. Come on. He's got more.
Yeah.
What's this?
So another thing that we have on display today, which is our Gold 2 latch, which is a
External latch.
So it's an external payload latching mechanism.
Like literally like a latch.
Right. So it has an active side and a passive side. So it allows the transmittal of data and power. So this one's set up. We'd have your power ports, your data ports. You have the passive side right now sits on like the International Space Station, where we have 20 of these up in space today.
Hang on a second. So this isn't just for closing the door.
No.
This is like got power. And so say that again.
So it has power and data capability. It could be custom designed however you need. Whatever that external payload that's going to mount, in this case to the International Space Station, has that connectivity. So you can power it up. You can transmit data back and forth between the external payload system, whatever that may be. There's a variety of it. So what would happen is...
Before I interrupted you, you were going to tell me how many were on this.
There's 20 today on the International
20 of
Space
our
Station.
Oceaneering Gold 2 passive side, and then
The active side.
active side are on the space station right now.
Well, at least 20 of the passive sides. Right now, everything's connected. So there is on the active side as well. So essentially what happens is the active side the payload that's coming to dock with the International Space Station would lock in. There's a conical device that actually connected with the robotic arm on the International Space Station and locks it into place so that once it's fully protected. So as a passive side, you have your orbital debris covers. So that way it protects from any orbital debris getting inside while it's sitting there in the low Earth orbit waiting for bad things to happen.
We do the coolest stuff.
We really do.
I'm being good. All right, now I'm going to let you off the hook. Thanks a lot, Tim.
Hey,
I appreciate it.
no problem. Thank you.
The USVs, I hear that you're the man, Alex. Tell me. I mean, look, everybody sees pictures of these. This is a whole lot big. Look, this is a whole lot bigger than most people think it is. What is it? So it's an uncrewed surface vessel. An uncrewed surface vessel, yes. It's essentially a boat that can go out autonomously and conduct survey operations. Okay, go ahead, explain it to me. Yeah, so we're intending to use it in a number of different ways. So we're going to be using it for nearshore survey, so being able to map the seabed where larger vessels can't go. And also we're going to be pairing it with our autonomous platforms as well. So we're pairing it with Freedom.
Why do I want this though? Why don't I just want a crewed vessel to go out there?
Yeah, so at the moment we're looking at the efficiency gains that we can get with this. So we're looking at how we can use a smaller, more efficient vessel to do the same task that we're using a large 60, 70 meter vessel to do. And also then freeing up the main vessel to go and do a second work scope at the same time, which then allows us to dual lock the assets that we have so they can go and complete the work scopes faster, more efficiently, and then move on to the next work.
Okay, and then not quite as impressive looking as this, but what is this one over here?
Yeah, so this is what we call the DRIX deployment system.
DRIX deployment system.
So this is the DDS that is essentially the launch and recovery platform for the DRIX that you've seen.
Okay, so explain more to me, okay? I need to, pretend like you don't need to pretend. Pretend like I'm 14 years old, okay? Explain to me what you mean by that.
So, essentially, when we're launching this from a mother vessel, we need to deploy the DRIX in a safe manner.
Okay.
So, we have this platform, the DDS, that has a 2-point lifting davit. So we can deploy it into the water, and the Drix can then come out of the back. So if you come around the back, you can see,
come on, let's go.
You can see the fact that the platform is actually open back, which means that the Drix can come out autonomously.
Oh, okay.
And then go off on this mission.
Ah, now I understand. I didn't walk back here before, but now it makes total sense. That fits right inside of there.
Exactly. And that then means we can then lift it back out of the water in a nice, safe, controlled manner.
Wow.
And do the maintenance and refuel on the main vessel.
Impressive stuff, Alex. Sorry to take you from getting your bottle of water.
No.
All right. Thanks again. Oh, I need to take your microphone from you. Thanks, Alex. All right, take care. So Rod was going to ride the PeopleMover, and we're going to ride it with him. You guys, come on.
Let's go for a ride.
All right, let's go. But inside the PeopleMover, it's nice and quiet. I saw you running in here. I figured I'd ask you about what went on today. What'd you think?
It's been fantastic. I memean, you always talk about these things and you talk about everything we're going to show, but when we actually see everything that's come together and everything, all these things that Oceaneering does in one place, that's pretty magic.
Well, I was going to ask you because, I mean, we're doing this in lieu of OTC, if you will.
Yeah.
Typically oil and gas, but we've got this here. We've got McMenemy here. Why did we bring all this technology here?
Well, I mean, it was convenient to do it during OTC because we're going to have a lot of Oceaneers in town from around the world. We're going to have our board here for our annual shareholders meeting, and then we're going to be able to bring in some investors. So the timing was perfect. But it's a 60-year anniversary celebration, so this is all of Oceaneering.
It's been fantastic. I think we had 560, I think, Oceaneers sign up to attend today. We had 200 and some odd customers last night, and then we had another about 200 today come visit this facility. What a great time.
It's really hard to capture that many people. And I got to tell you, I was walking around just going from table to table over lunch today, asking the customers what they thought. Most of it was, I always wanted to ask, what surprised you? What did you not know about? And almost everybody talked about an aspect of Oceaneering that was outside their normal job that they didn't normally see. The other thing that I got that I thought was really special is they talked about how much we've invested in technology. I think all of them came away with, you really are one of the coolest technology companies out there.
And that's true.
Absolutely.
All right, and look, Kyle, we're in the PeopleMover, right? And so Rod was kind enough to do an interview for me earlier. So I'm going to let him ask you about PeopleMover. I'm going to put you on the spot, my man.
Absolutely.
So take it away, Mr. Larson.
So, I mean, it's really easy to get excited just by looking around about what we're doing and why this is such a cool thing for Oceaneering. But tell people when other people are looking for transportation like this, what makes this different?
One of the things is this is a fully automated system. So most of our competition rely on safety operators. So they use a level 3 automated system. This is one of the only service-proven solutions that's fully driverless. So you reduce persons on board that we're familiar with in the oil and gas industry. It's safer, more reliable, higher availability. So those are the things our customers really need in a high capacity, high reliability system.
So tell us about where would this operate? I mean, what would an application be? Can it operate around other vehicles? Can it operate around the pedestrians? Where would somebody put this to use?
Most of the applications we see are for airports, transit authorities, private campuses, much like this, where you need to get from facility to facility. Regarding the hazards and the capabilities of the system, it's designed for a private guideway, so not on the public road, but it does have an array of sensors, so it can detect obstacles and avoid them, so it is safe to operate in a mixed environment like this. But really any application where you have a high frequency demand, high reliability and uptime, need to move some people. This is a 22 passenger vehicle, so it can really deliver some throughput capacity for the customer.
So it's really about a really smart machine, right? So How long does it take you to set up a route like we're running today?
We were able to set up this route in about a week, and that include the setup, the installation, test and adjust the tuning. So it can be a really fast process, and it doesn't rely on a lot of infrastructure to do that, which makes it very flexible.
Very, very cool. And so what's next? Where do we go after this show?
We're speaking with multiple airports and working with them on the design process. So the next stage will be to build the shuttles and actually deploy them, operate them for long-term operation contracts.
Very good. Yeah. Well, great luck, Kyle, and thanks to the team for bringing this down, or we can actually have a ride.
Thanks so much. Appreciate it.
And without Phil, none of this would have happened. So we're going to go stick a mic on him. He just doesn't know it yet.
No.
Come here, Phil.
No, Phil. You're not gonna away. No, you're not gonna get away with setting all this up and your amazing crew of people putting all this together. Phil, an amazing job by you and your team. Rumor has it you were out here till 3 o'clock in the morning putting this together.
That's a rumor.
That's not true? No. Not true? What do you think about all this? I mean, we basically shut down your facility for a couple of days, but overall, was it worth it?
It was worth it. If you see some of the smiles that were on our customers' faces today and the smiles that were on our employees' faces, they seeing everything that we do all in one spot, that made it all worth it.
And I think it was you told me that they manufacture pieces and they don't necessarily know where they go. Tell that story again, because that was really good.
Our global machine shop, right? So those guys are manufacturing bits, right, or pieces to most of our kit, and being able to see those pieces in a full assembly, you know, that was exciting for them, and to see them smile about that and give them a thumbs up and feel good about the work that they're doing. Yeah, it's pretty awesome. Well, it makes me feel good.
I wanted to make sure you got the recognition you deserve, you and your team, for making all this happen. And so as your reward, I stuck you on camera.
Yeah, I know.
All right, Phil, thanks so much. Okay, so that sums up the tour. And basically, I just wanted the people that couldn't be here to kind of experience for themselves through the lens of everything that we do, all that goes on, all the technology involved, and all the things that we do in all these different harsh environments. It's been an amazing time. We have another day tomorrow with investors and the board of directors even coming. So again, I just want to thank everybody that had the opportunity to make this happen. It's been an amazing time. Thanks again, everyone.